Welcome back everyone. This is a continuation to the previous video where we have seen singly linked list deletion, and under singly linked list deletion we have seen deleting the first node. Now in this video we are going to see how to delete the last node of a linked list. So when we want to remove the last node from the linked list, that means in this particular example, I want to remove the 40 out of the list. This operation is a bit trickier than removing the first node because algorithm should find which is the last node, and then only it can remove the last node. So this can be done in 3 steps. First step tells to traverse the list. You might relate it with the previous video on traversal, or you might also relate it with a video on insertion at end. So when we are in that particular video, when we were trying to insert an element at the end of the list, we traversed from start till the end and then inserted there. So in the same way here also we have to traverse from start till end, but there is something extra that we need to do here, which is similar to what we have done in the previous video, where we were trying to insert an element in the middle of a list, that is at a particular position. So here the step tells that to traverse the list, and while traversing maintain the previous node address also. So why are we maintaining the previous node address? Because to speak generally, if we want to remove the last element, all we have to do is make this next pointer of the previous node to null. That means if we can make this, let us show it diagrammatically. If I can make this next pointer point to null, then this connection will be lost. And if this connection is lost, that means this particular node is not anymore connected to the list. And because this particular next is pointing to null, that means this becomes the last element, new last element of the particular list. So that is the basic understanding of implementing the last node deletion of a singly linked list. So to do this, our steps are, we have to maintain the we have to traverse from start to last, as well as we have to maintain a particular pointer which points to the second but last node. So by the time we reach the end of the list, we will have two pointers. One is pointing to the last node, other one is pointing to the node before last node. Okay, so this is exactly what we need to remove the last node of a linked list. The second step tells that we have to update the previous node's next to point to null. As we have seen in the previous slide, we want to make the next of the previous node to point to null. So in the same way, here that is the second step. We have to make the next of the previous node to point to null, and then dispose of the last node. So once we have made this connection, this is not needed anymore, so deallocate the memory of this particular node. So these are the three steps that we need to maintain. So let us go to code blocks and see how to develop these three steps into a program. Okay, here we are. I have given the name of my function as remove last, and these are the 3 steps. As you can see, the first step tells that we have to traverse the list and maintain the previous node's address also. The second step is to update the previous node's next pointer to null, and the third step is to dispose the last node. So to traverse and maintain the previous node, that means we have to maintain 2 pointers, one which is pointing to the last node and another one which is pointing to the previous node to the last node, and so we need 2 pointers here. So let us create 2 pointers of list node. I'm creating one which I'm calling it as previous, another one I'm calling it as current. Okay, and then I have to make one of the pointers point to the start or the first node of the list. So I'm making current point to start. Then I have to traverse. So I'm writing the traversal code where I have to start uh, from current equal to start, that is the first node, and I have to go till the last node. So I'm checking until the next of current is not equal to null. So that will tell us whether we have reached the last node or not. So next of current not equal to null. Okay, so as long as next of current is not equal to null, I have to keep moving to the next node. And to make the current pointer move to the next node, our code is to make current equal to currents next. Okay, but even before moving current to the next node, as we have seen in the previous video on insertion of a particular node at a position of a linked list, we have seen that we have to update previous first and then only make current move to the next node. So here we are doing it. We are making the previous point to the current node and then moving current node to the next node. So this code basically completes our first step, traverse and maintain the previous node address also. By the end of this loop, by the time this loop is over, previous will be pointing to the node which is just before the last node, and current will be pointing to the last node. After that, we have to update the previous node's next pointer with null. So currently previous is pointing to the previous node, which is just before the node of the last node. So we will say point the next pointer of previous with null. So we will say previous next is equal to null. That was our second step. The third step is to dispose the last node. As you know that the last node is being currently pointed by the pointer current. So all we have to write is free, and under free function we have to pass parameter as the last node is currently pointed by current, so current. So let us go to our test program where I want to test it. I have already written the remove last function call before, so this is what I am doing after calling the remove first, because I want you to show both the differences. That means if I remove first, the first element gets removed, and then the display is printing the latest number of elements of this list, as well as after that I am using the remove last function where I am removing the last element of the current list, and then I am displaying the list contents once again. So let us run it and see. As you can see the result here, it's pretty clear. The first display is printing all the elements which were inserted previously, and then we have called remove first, which is which is removing the first element, which is nothing but 4. So After 4 is removed, the next display is printing 8, 15 and 7. After that we are calling remove last function, which is removing the last element. As we can see, 7 is the last element of the current list. So 7 gets removed, and once 7 is removed, this display prints the current list elements. So currently list contains 8 and 15 only because 7 is already removed from the list. So this is how our remove last function works. So this is your full code of deletion of a last node from a linked list. Thank you.